everyone. This is basically a background jobs one-on-one talk, a gentle introduction. If you know nothing about background jobs, that's completely fine. And if you do, great. I'm Sylwia Vargas, and I wanted to share some information with me before we start. So I'm really happy to be here and talking to you. I love pierogi. I have a pigeon family living on my balcony. And you may also know me because I worked on the new React docs. This is the page. And previously, I worked at StackBits, where I was running the DevRel team. And currently, I am doing that at Ingest. One more fun fact, hopefully, about me is that I love working on side projects. It's all joy and fun. In fact, I'm working on one right now. And you don't have to worry about all the business needs. You can just focus on the user experience. And because you are oftentimes your own and only user, you'll always be happy. Well, this is not the case with the real world production apps. In real product development, what the user sees is usually just the tip of the iceberg. Most software is so much more complicated and scarier than we think because of the business requirements. So let's look at the real life scenario. Imagine that you work at a hot new restaurant booking app. The app is Next.js because everyone who works there at that startup is a hipster. Your boss asks you how long it will take you to build a new sign-up flow. So you get a list of the requirements from the product manager, you look at it with an iced latte in your hand, you stretch. So let's see. You have to securely authenticate the user. You have to add the user to the database, then to the mailing list, and send them a welcome email. Okay, thankfully, building this today is so much easier than it would have been 5 years ago. Because you can use Clerk for authentication, Supabase for the database, MailChimp for the mailing list, and Resend for email. Well, great work, job done. You can take a big sip of your iced latte and go back to playing Wordle or reading one of the 1,000 mega threads of Dan Abramov on React server components. But here's the code. You'd create a user in the database, send a welcome email, and then add member to the mailing list. So this looks very simple, and we like simple. Building applications using third-party services is smart because it makes your life easier. And where's the problem? Well, the downside is that we now created a distributed application where we have no control over large parts of the infrastructure we rely on. For example, sometimes even on a good day, services can be slow. Sending an email can take half a second. So we have a problem. We have blocking code in the critical path of the request. As a result, we are making our API slower. In other words, our user is wasting time. User experience should not suffer because of the business requirements. So how are we doing so far? Is it fast? Well, no. But is it reliable? Also no. Imagine that as you're adding a user to a mailing list, the service goes down. Now you can manage retries 1, 2, 3, 4 times. And what if something fails permanently? Now you need to figure out how to log this error to logging service. And you need to figure out the recovery system. So now the estimation to build this very simple feature goes into weeks instead of days. You need to set up all the infrastructure and processes. Also, partial failures can be really bad. You've added the user to the database but haven't sent them an email. So now you have 3 options. First, you can ignore the error, which means that the user is not on the mailing list and they don't know about that. Second, even worse, you can show the user the error, which will lead to a lost customer. Or third, worst case of all, the user will try signing up again. So let's assume that the user gets the error and tries to sign up again. Well, now the db.user.create will error out because there's a duplicate. Well, good luck recovering from that. So this is the mess we are in. The app takes forever to work. It takes me forever to build it. I will be slower at my work because I will be dealing with the support backlog, and we are still not dealing with persistent failures. Everyone is unhappy, my boss is unhappy, I'm stressed, and I'm losing sleep. But there is a solution. We can make our code faster and more reliable. Let's move non-blocking tasks to background jobs. So typically when we talk about background jobs, people think about message queues. Queues are great in data-intensive processes that don't need to run on the main thread because they execute asynchronously. In lay terms, queues work like this. You have, you know that once you add something to the queue, it will reach the destination one by one. So what's happening in the queue does not impact other parts of the infrastructure. The delivery is guaranteed. But what happens when the message reaches the customer is still up to you. The drawback here is that once you take something from the queue, the rest is on you and the queuing service does not care anymore. This means that the queues work great when your application is simple. When it grows in complexity or if it's distributed, when you become successful, fingers crossed, all of a sudden you have to worry about a plethora of additional infrastructure that you need to build. For example, concurrency, because you want to be able to control how many steps are executed at one time, or state persistence and state management, because now that you are dealing with a complex application, you will need to share state across different functions and queues. Or, for example, error handling, because what if another service goes down and you have to figure out, you know, the retries for failures and timeouts. So this is a lot of work. But there is a better solution, and that is durable workflow, which combines durable execution and flow control. Durable execution is similar to message queues. Instead of having to decouple your reliability infrastructure from your application, you can define it as part of your code, so inside of your code base. And, you know, durable execution is now a trendy paradigm. In this talk, I will use Ingest as an example, but there are other providers. In fact, Cloudflare just announced that they will be releasing durable workflows as well. Fortunately, Cloudflare's API is the same as Ingest, so you can just go ahead and play with it right now. So anyway, let's move the non-blocking tasks to background jobs. First, let's add Ingest to the project. Ingest is a reliability layer to your app. With Ingest, you define functions and workflows using its SDK right in your code base, and then serve them through an HTTP endpoint in your application. Ingest then takes care of reliably executing functions asynchronously. So there's also a dashboard, as you can see, where you can monitor, debug, and manage your jobs. So this is how your app looks like right now. We are going to add a reliability layer, which is Ingest. First, we are going to wrap this function in ingest.createFunction. As you see, we are providing an event name. Later, when a user signs up, we will trigger an event with this name. This will tell Ingest to execute this function. And this is how it looks in code. We are creating the function, we are providing the event name, and we are invoking our existing MailChimp code from before. And now we'll do the same for the other function. And here we are using the same event name, as you can see, because we want these two functions to fire at the same time, which is when the user signs up. So this pattern is usually called fanout. So this is how it looks in code. Instead of invoking these functions directly, we trigger an event in Ingest. And like I mentioned before, we expose our functions to Ingest as an HTTP endpoint. Ingest then uses this endpoint to execute specific functions when an event was triggered. So this is the endpoint. Ingest will use this endpoint to download the function definitions and execute them. And here we can see the complete flow. Ingest calls the correct functions in the precise time you want. And then on the dashboard, you get notification that there was an event triggered, which in turn called two functions. And we see that they completed and also when that happened. And so what happens when there is a failure? Well, let's look at that. Ingest invokes a function and it fails with an error code. Ingest will retry it and retry it until it succeeds. And you don't have to worry about it. Moreover, you will also get a detailed log of what happened. Yeah, I know it's difficult to believe, but sometimes the errors are persistent not because of some outage, but because there are bugs in our own code. I know it's hard truth. In these cases, you can actually easily debug it with Ingest console. And once you have fixed your function, you can recover by retriggering the failed event, so no data is lost. So we wanted to make our app faster. We moved non-blocking tasks from the user's critical path to background jobs. But also we got reliability as a nice addition. And now we have access to this great infrastructure. So let's see what else we can do with this great infrastructure we have in place. So this is our app right now. And I didn't tell you yet, but Ingest actually allows you to schedule tasks in the future and orchestrate multi-step processes. So let's look at the send email. Here we are just sending a welcome email, but it's always nice to increase user retention if you've ever talked to any product manager. So we could send them activation email drip campaign in the first week. So how would we go about that? So let's create an ingest function which will react to the same event. So far, we have been talking about the pattern that's called fan out, but in that pattern, you have multiple functions firing up on the same event. However, many tasks actually require sequential progression. Here, we are building a marketing drip campaign, so it's convenient that we can express the whole timeline in a procedural code. So we'll use ingest steps within that function. Here we are using ingest step.run. In this way, the code will get automatically retried if it fails, but the code that runs successfully will never be retried again. I will show you that in action in a bit. And first, we are sending the welcome email. This is the same part we did before. Then ingest will pause execution of this function for 4 days. Here we are using step.sleep. From a programmer perspective, it may look similar to just using set timeout, but actually in the background, it just handles the scheduling for you. So that means that your serverless function does not run for 4 days, and you don't have to sell your kidney to pay your AWS bill. And the last step is the final email with tips. If there is a failure in one of the steps, Ingest will know that the other steps worked and will retry only that one step until it works. And so now we have built a successful drip campaign. But we can do better. Imagine that someone has already signed up and immediately made a booking. It wouldn't make sense for them to receive the same email as someone who didn't finalize a booking. Maybe they need different types of tips or maybe different types of CTAs. The campaign could be dynamic and based on the user actions. So let's do it. Let's delete the last 2 steps because that's what we like to do, deleting code. So elsewhere in our app, let's assume that when a user completes a booking, there is an event sent called booking.created, just like user.signup. So now we can use this event to determine the course of action. Here we are waiting for 4 days to see if the event will happen. Next, we will use the booking event to determine the course of action. If the booking was made, we will reward this person with power user tips. And well, if they need 4 days to make a booking, they need some basic tips. And honestly, this is so much fun that why stop there? We could go wild and create lots of emails with lots of tips. And speaking of tips, this is all just the tip of the iceberg. Here we are talking about sending emails, but Ingest is not a tool for sending emails. There are numerous use cases that go beyond just marketing campaign. You can build complex payment flows, LLM prompt chaining, or multi-step data transformation. Whenever you need to have a bunch of stuff happen in response to a given event, you could consider Ingest. For example, SoundCloud uses Ingest to streamline generating dynamic videos, or when using AI in sales flows, or Resend, the email sending platform, which we also use in the example today, uses Ingest to verify email domains with serverless workflows. Ingest works in any cloud. It's also framework agnostic. Finally, it is also language agnostic. In this example, we saw a lot of TypeScript and type safety. But in addition to TypeScript, we also have SDKs for Python and Go. We are also looking to add more. Fun fact, actually, you can mix and match them in your workflow. So you can invoke functions written in different languages. Also, our SDK is open source, so we are looking for contributions. And there's also a local dev server, which doesn't require you to log in, so you can actually just go ahead and play with it. I spoke a lot about Ingest here, but this talk is not about Ingest. When building real-world production applications, reliability is really important. Not only does it keep your users happy, it also makes your team more productive. And you, a developer, you are less back down with maintenance and operations. But achieving reliability is hard. Every engineer who ever had to build a reliable system at scale knows the amount of iteration and infrastructure work that goes into it. In this example, we used Ingest as a reliability layer. But whether or not you use a third-party solution, sooner or later you will need one. Reliability is like security. It's really hard to add afterwards. So baking it into your architectural choices from the get-go is actually usually a very good idea. In times like this, when engineering budgets and headcounts are being cut down, we as individual engineers need to do more with less. So just as you're probably outsourcing your emailing list or email sending to cloud vendors, it is worth asking yourself, do you really want to be in the business of operating your own queues? And Matthew Drucker, the CTO of SoundCloud, thinks you shouldn't. And if that's the case, why are so many people still using queues? Well, queues have been around since the 90s. And, we are used to that. And when we are used to something, it feels familiar and cozy, even if it's not the coziest solution. And you deserve coziness. To go back to the beginning of the talk, I really like to work on side projects because then I can focus on user needs, my needs, instead of all the daunting things like reliability. In 2024, we deserve all fun and joy in our day jobs too. And so thank you all. Let's be friends. Reach out to me on any of the platforms. Thank you.